Well, that's how it is. Okay, we are recording now. Okay, well, welcome everyone to like the first official front end Friday, and just kind of to set expectations for this. This started really was Russell and I just wanted to share off cool code and drink beer at the same time, and so like this is going to be kind of a big session today because it's our first one. But it'd be nice if these weren't quite so big because they take a long time to plan, and that's time I don't have. So just to kind of set expectations as well, like this isn't a Pluralsight course. You know, I didn't spend hours and hours, you know, writing agendas and stuff. This is going to be kind of showing off code that I've done this week that I think is going to be interesting and relevant. So please ask questions. And then, you know, down the road, it'd be nice if it was not just me showing off cool code. You know, Russell taught me a lot of what I know about RxJX, so I think he's got some cool stuff there. I know Brandon's been doing some pretty cool stuff with asynchronous validators in Angular that I have no idea how to do. So it'd be nice have it not just me trying to figure out what am I going to talk about. That said, I also have a list of cool topics that I want to talk about. So if they're, you know, if you have a request like, hey, Gerald, I'd love to know more advanced RxJX stuff. Cool. We'll plan a Friday session. So I hope to start doing these regularly. We'll see though, as time and energy permits. You know, I've got another month left on Atom, and you know, the last month is always crunch month. So we'll kind of see how that goes. So anyway, that said, diving in. So the plan I have today is I want to show off some of the map work that I've been doing for Atom. And it's a really interesting approach because we're using Azure Maps. And why don't I go ahead and share so I can kind of, all right. So I can show you a little bit about the project and kind of the interesting challenge. What's interesting about Azure Maps is there's no corresponding Angular component. So if you've worked with Google Maps, you know, you can download some library and, you know, do some stuff and go from there. I had to build this from scratch. So I thought that'd be kind of a good exercise for, you know, I've had some people ask me, hey, you know, what's the approach to how do we build reusable components in our UI library, input outputs, all that kind of fun stuff. So I thought I'd go into that. So before we kind of dive into the mechanics, let me actually show you a little bit of the application. So what we're building here is an equivalent to like Redfin or Zillow, where you want to find properties that are for sale and you want to buy them and usually flip them. Now, what makes RealtyTrack a little different is they focus on bankruptcy or foreclosure or stuff like that. So you can see here on the right, I have my listings. Clicking on a listing takes you to you know, a property details page with information on, you know, all the property information, kind of what you would expect. And then most of the bulk of this app, I'd say a good 70 to 80% of the effort on this app has been this map work over here. And so you can see here we have server-side clustering, data updates, polls, refreshes, pins breakout, provided the data loads. Come on. There we go. Okay. Oh, look. Hey, this. Oh, look. 1.3 million in Southern California. What a steal. Oh, look. Property here. Oh, okay. I want to do another search here. Let's look for, you know, these. So we have a real-time type ahead here against the back end. Clicking on this pulls in map data. You notice up top we have routing, pops boundary information. So I mean, this is probably one of the, I would say, out of all the projects I've built for InnerSoul so far, this is by far the most technically complicated. Most of our other projects, you know, are standard CRUD type apps, and it's pretty straightforward. Get data from the API, modify it, send it back. And one thing that makes them easier is we can kind of break them down into smaller components. What makes this map huge is there's just a phenomenal, there's thousands of lines of code of business logic behind it when you click this. And the other part of it is I'm dealing with a substantial number of side effects and race conditions where, you know, when I click the remove boundary button, that fires off an API call, which does a bunch of things. And there's 2 or 3 API calls coming back at different times. And depending on the results of those, I might fire additional API calls, which may or may not fire other API calls, which may or may not do other things. And so it's just a huge web of logic, but there's really no way to reduce the complexity of it. So anyway, so that's kind of the business rules. Map's kind of fun. So I want to go into, so let me look at my agenda here today. So let's talk about how to build reusable library components, and then kind of I'll go through the gotchas, like this library component uses a state management tool, or the one that I built, and we'll just kind of make it useful for there. So first thing to know, so let me go ahead and pull open code here. So you'll notice that this follows our standard convention for reusable components. So if you notice my project structure over here, here's all my project components in here, and they follows kind of our standard convention. I think I should probably need to delete map. And so Azure Maps. So, being a engineer at a consulting company, I'm like, this is not going to be the last Azure Maps implementation I ever do. How do I save myself a ton of head desk on our next project? So, and that's where this comes in. Now, the real challenge of a reusable component like this is figuring out what business, and this is really the cornerstone of building a UI library component, is what business logic is specific to the business or the implementation that I'm working on, and what is something that could be used for everyone. And figuring out where that line is huge for kind of determining your component is. So let's go ahead and start. Let me go and dive into the components here. Want to call it a couple of things here. One, all of our reusable component libraries start with an NTX prefix. So NTX means inner soul. And when you see this, hey, this is a library component that's shared between multiple apps. For standard components that you use in your project, you're going to use the app prefix. So when you see that, it's good to know. Follows kind of standard conventions for stuff. Those URL standard here. Something that I've been having to do more and more here is to disable view style encapsulation. The big reason for that is a lot of the components or wrappers or things that we build around have their own styling, or you need to override it, or they may not have, or they may have code that exists outside the scope. And so what you want to do is kind of sort of manage your own scope for that. So if we look at what that looks like, so you disable view encapsulation, and then in your CSS file, you have some sort of master class. And then that avoids a lot of collision risks for that kind of stuff. So, okay, change detection on push, of course. So let's go over just some example inputs. And you'll notice that I use my own models for here. So let me show you what some Azure Maps code looks like. And it follows kind of like your standard Maps implementation. So if we look here, and you guys don't have to pay too attention to how maps work. Just want to kind of get a feel for it. All the map providers work the same. So I've done Google Maps, I've done Mapbox, I've done Bing Maps, and I've done Azure Maps now. And they all are like almost one-for-one identical to how they work. They have the same building blocks, the same structure, the same way they instantiate the map. And as proof of that, when we started this project, it was originally on Mapbox. And then about halfway through, they're like, no, we're switching to Azure Maps, which is a fantastic thing to do mid-project. It didn't end up being that big a deal to swap out because all their building blocks were the same, and I had abstracted the Mapbox code fairly well, so it wasn't a huge deal to abstract. So the way Azure Maps works is you get one, you have to load load their script on the page. You can put this script inside like your index.html file, but when you're loading third-party scripts, you really only want to load them when you need them. So like if you go to a lot of traditional map sites, like when you hit the home page, so if we hit the home page, let's go ahead and take a look at that. You'll notice that there's no map on this page. So users here shouldn't be forced to download a 2 megabyte map file. That said, we can do some sneaky stuff and load it in the background, but for the most part, we only really want to load third-party scripts when they're actually being used. And so here's kind of a common pattern for that. You just create it in memory, pop it in, and you'll check to see if it exists first, and then you'll initialize it. And the way all map providers work is they attach themselves to the window instance, and then they provide these giant objects that you use to sort of generate and interact with the map. So in this case, I'm creating a new map by instantiating it here. Here's all of my configurable options. And then at that point, I go down my list here and say, okay, add click events, add state change options, all that kind of stuff. So first thing that when you're building a reusable component, especially when you're building a wrapper around somebody else's component, is you need to define your models. So let's go ahead and see what those guys look like here. Okay. All right. So you'll notice, so here's my component, and inside the root component, I have my module file, and then I have a models file, and then I have an index.ts, which kind of exports everything just for convenience. Now, the trick with the models file is that it follows the same sort of conventions that we use for everything else. So I like to use modules as opposed to namespaces. The main advantage being is that there's pros and cons. Modules are actually compiled, so there's actually code that exists. But the reason why you want to use modules over namespaces is you can now access enums inside your modules. So because namespaces aren't compiled, like if I declare an enum in here, let's see if I did that. I might not have used one. Here we go. Perfect. So I have an enum called actions. If this was a namespace, I would not actually be able to use it, and I have to have a separate enum file, and then I have to merge the two, and it's just missing. Just use a module. Also, feel free to pause me and ask questions, because I tend to go pretty fast on these. OK, so first couple of things you need to figure out is what kind of inputs do I need to generate this component? So, and a lot of these will follow you guys would all expect in terms of reusable dump components. So if we go ahead and pop back to the main component here and we look at our inputs, you're going to notice that a lot of my imports correspond one-to-one to sort of the data types needed by the models. So I'll just go through some examples to these. Your API key. Maps need to know an API key. It needs to be passed in just so it can connect to the API, pretty standard stuff. Settings, I use these a lot in my components because oftentimes the component has a lot of configurable options. And in this particular case, do I turn zoom on or off? Do I can I pan and tilt? Do I want to enable certain configurable options? And so to correspond to that, I will have a settings model that then has all my configurable settings. So I'll just quickly look like an options. So options, pretty straightforward. Placeholder text to use the background tile while the map is loading. Default zoom level, what are the min and max zooms, marker configurations, pop-up configurations, bounds, controls, et cetera, et cetera, et cetera. Now, the whole point of this exercise is that we automate as much of the map build as possible. So when another engineer comes online or I get a future project and I need to build in Azure Maps, I only have to pull in this component and all the logic that powers this stuff is done. So for instance, there's a lot of work involved that goes into making markers and pop-ups work on this map. And I've done all that work. And so now all you have to do is configure it. And so the point is to save yourself a ton of time on a future build. So this is kind of like your setting files. So we don't have to go into this in too details. But the other thing to keep in note is that the settings file also corresponds one-to-one to what the Azure Maps implementation needs. So if we go ahead and look at the Azure Maps, so you'll notice that when you're instantiating a new map, it needs a unique ID, which I'm providing, and then it needs a settings object. And you'll notice that I'm providing that straight pass-through. So it makes it really convenient when you need to do two things. So one, Azure Maps needs a bunch of stuff in order to configure properly, but I also need a bunch of stuff that I want to automate so I don't have to do it again. And so having like a settings model like that allows you to kind of merge the best of both worlds. And then when your component gets, you can kind of extract out what you need when you need it. You'll also notice that I have documented this extensively. This is pretty important. So if you're going to be building reusable library components, somebody else in 6 months from now is, hey, Gerald, I'm on an Azure Maps project. What do I need to know? Well, you can just roll over. It's all JS docs documentation. So if I roll over, all these, you'll notice all the documentation is this, and it's all nice and neat. So, oh, hey, what's placeholder do? Oh, it's a path to an image to use as the background while the map is loading. Perfect. Takes a string, which is a URL. So it makes it really easy for future engineers to sort of figure out, hey, what's the, what's with that? All right. OK. So now let me show you where things get messy, because I have a corresponding. So this is the actual state component that managing its own internal state. Now where things get messy is now I have an Akita store outside that. Let's see, let me find it here, called map state. Now this is outside. This is in the route. This is the global store. And just to show you how big this app is, this guy is a good 700 lines of code, and there's probably another 2,000 lines of code that are sort of abstracted away. And this is where we manage the deltas between sort of realty tracked implementation of Azure Maps that only realty track needs, and something that another engineer working on Azure Maps that won't need. So for instance, like, let me give you an example. So let's go ahead and punch in here. All right, so something that like a good example of business logic where it needs to live is like this remove boundary button. This is not something everyone's going to want on their Azure Maps implementation. So where does the business logic for this live? So this lives outside that. So when I click remove boundary, it's going to remove and make a search and stuff. So an example like that is, so I probably don't want to build the logic for that inside my Azure Maps component because it's highly specific to this particular implementation. And so I let the external component handle that. Any questions so far? Cool. Makes that much sense, right? Okay, so let's talk about like parts of a map. Now let me check my notes here. Okay, so let's talk about parts of a map and then how the model and how everything plays together. So anytime you're doing any map work, a map is composed of couple of main building blocks that you need to be aware of. So one is HTML markers. You guys have all interacted with these guys. You know, if you do a search on Google Maps or something, you'll see a pin that pops up, and then when you click on that pin, you know, does some stuff. They are also composed of layers. And what a layer is a layer is exactly like what it sounds, where it describes some piece of metadata or like boundaries, or it's usually, it's like almost like a CSS file for a map, where it describes, okay, hey, this border should have red border and it should look like this, but it doesn't actually have any data in it. And then the data sources is your main source of information for the map. So if you guys are ever having to do a map implementation, these are your main building blocks. And so the way it works is you provide layer that says, okay, let's look at an example of that. So a layer is, let's do a search for, okay. So if you notice, I have this red boundary here, and that is an example of a layer. And then the actual border itself is being driven by a data source that changes. And so the nice part about the way this is structured is data sources are constantly changing as, you know, the user interacts with the map. But I don't have to change layers and markers because we're only doing the deltas. So it's extremely performant. Now, a couple other things to keep in mind here is, what are some configurable options that the users are going to, you know, that other designers of this app are going to need to do. So they're going to be able to change camera options. What if we want to change the location of the script URL? So you notice I have a syntax here where this is where their default CDN is. But what if you know, a future company goes, oh, hey, I want to host it myself. So it defaults to this, but you have the ability to override it. Same thing for, you know, something like this. Maybe we don't have any default settings. Maybe we do. Okay. So what if I want to disable the map? What if I want to resize the map? So one of the reasons why things like these are useful is disabling the map is actually a huge pain in the butt. There's actually a lot of logic that goes into that. You have to instantiate the map. You have to do a bunch of stuff to it. And so this is why abstraction comes in useful. So as far as a user of this library is, they just have to pass true to this map, and all that business logic, it gets fired and they pass false to disable again. But then they don't have to sort of wire up all that logic again. Okay, and then the next piece of something like this is obviously like our outputs. These are all the events that we care about. And something to keep in mind, like for a big map like this is not comprehensive of everything. You know, I'm not a library author. I'm not building this for thousands of people. So I'll basically only bring new events online as I need them. So for instance, you know, layer event change, when somebody clicks on a marker, you know, when somebody hits mouse enter, double clicks, pop-up clicks, loaded, zoom in, drag in, etc. Basically anything that the parent component needs to react to state changes. Oh, excuse me, throat's getting dry here. And then they can change the inputs. And so the way it works is, let's say a user clicks zoom in the zoom. Then the parent component can say, okay, how do I handle zoom? Well, I'm going to make another API call. The API comes bulk with new data sources, and then new data sources come down. And this way I kind of keep everything nicely encapsulated. So the Azure Maps component only cares about things that are relevant to it. And then the parent component can figure out how to react to events and what changes need to happen. Now, a word on the models. So if you notice, I'm using the NTS prefix, Azure Maps with a component, and then, you know, my own name for layers and models. So if we look at what these look like, and this is a key thing if you're building an abstraction around somebody else. Let's see here. Let me give you an example. Let's see here. So here's an example of a layer source model right here. We need to know what type it is. It needs to have source ID attached to the data source. We need to know the ID of the model, etc. Blah, blah, blah. What this model is this is actually corresponds one-to-one to the new class needed by Azure Maps. And the advantage is it's a best of both worlds. So Azure Maps needs these properties. And then I have added these because I need these properties. So for instance, Azure Maps does not give you any ability to emit events. So what I need to do is I need to attach my own event emitter. So essentially taking your models and wrapping them around what the source models needs gives you a lot more flexibility and autonomy in how you do it. So for instance, let's see here. So you can see here, here's an example of one where I'm using their models. So if I were using their models exactly as inputs, like, so for instance, instead of using my own wrapper around their models are actually pretty rigid, and they don't give me the ability to add more things that I need to do, like attaching event emitters and stuff. So a quick wrap around like this saves us a lot of kind of trouble in terms of, creating your events. The other problem is that Azure Maps requires classes. So so when we attach a layer to event, what Azure Maps does is it doesn't give you like a JavaScript object. It doesn't want, you have to create a class. And one of the big problems with that is classes do not do well in any sort of state management platform like Akita or anything like that. Yes, I am recording. Okay, so one of the things is when you generate a class adds all kinds of, like, it gets messy. So what these guys do is by generating sort of a pass-through layer, it solves all kinds of problems with either poorly designed lower order components or that sort of stuff. So for instance, let me tell you what happens. When you give Azure Maps a class, it starts mutating that class. It attaches map instances, it runs functions. And so now if you have passed that class, it has mutated your class. And if you try to go back and access it in your parent component again, all things of unpleasantness occur. So that's a problem with two-way binding. So by adding your own abstraction layer, you just sort of solve the big problem for that. All right, let's see. Okay, map provider, data sources, covered that. Geocoordinates, polygons, markers, and more. Okay, so another key thing that I want to share is state management in lower order components. So now we've, I know everyone has kind of varying levels of familiarity with NGRX and Akita, but I think everyone is at least aware that, we like using flux pattern observable data stores in the parent component to manage state, Akita for setting key value pairs, observables for doing all that kind of stuff. Well, library components need to manage their own internal state, and it gets a little bit, it's a different problem to solve than like your parent order state. And the reason for that is a couple other problems here. One is we don't want any third-party dependencies. So, we used to use NGRX, 2 years ago before Russell discovered Akita. And, Akita is so much simpler. But when we build these components, we don't know what our requirements is. So let's say we go into a client and they say, well, we don't want to use Akita or NGRX. So what do you do if you have a lower order component that has a dependency on that? Well, you're kind of screwed. The other problem with that is that NGRX, is a pretty terrible offender when it comes to like how much boilerplate it uses. It's a huge amount of work to wire up. And one of the other problems with NGRX is all its stores are on the global scope. So if you have a dozen components, that using NGRX, they're all going to be receiving and responding to actions from your entire site. And that's just a terrible pattern. Akita is a little better, but again, Akita still has a lot of, Akita's also has a very fixed design pattern where, it's looking for key value pairs. It has a simple update pattern, and maybe it doesn't quite fit your use case. So I like to do, at least what I've started doing further, is I like to roll my own state management pattern. And this gives me an opportunity to show you guys kind of the couple different ways of approaching to this, because I like this pattern, but I wouldn't use it for anything. So a couple of big gotchas, and this is a really big gotcha. So like if you're taking notes, write this down. Do not use services in lower order components. I can't stress that enough, underline it really big. And here's why. Services are singletons, and they're also persistent. So singletons mean you can only have a single instance of it. Well, one of the requirements for reusable library components is you may have and often have multiple instances of that component on the page. So let me give you an example. So this map component, you're like, oh, there's only one map. I can use a service, right? Well, no. One of the requirements is on the property detail page is we are going to put a little map right here. So if I want to reuse my map component and I have a service, guess what? Both instances are going to be using the same service, and they're going to be fighting for state. The other problem is that services are persistent. So, you can encapsulate a service with a module, but most services are on the global scope. So this is why we have that injectable, and it says, provided in root. And what happens is that means that service exists even after the components using it are destroyed. So one, this is a huge risk of memory leaks, and two, it's not tree shakeable. So for instance, like let's say I have a service and I've got 50 functions in there and I'm only using 20 at a time. Well, you can't tree shake functions in a service. So it's going to get larger and it's always going to be stay there on the global scope. So what's an alternative to that? The alternative is just a class. So if we look at this guy, so let me show you what I'm using for state management. Real simple. Export class, Azure Map Store, and it follows normal class rules. Okay, like public events, I have a constructor and I have a function. And then just a pattern I like to use here is I like to abstract away the use of the new keyword. It's minor, but if I ever needed to change this to not a class, for instance, like if I decide to use as a more functional approach with like object composition, I'd have to find every instance of it and kind of replace it. So what this looks like is when I need to create a store, if we go back to my Azure Maps component, it looks like this. That's it. So on when this component's instantiated, it creates a new instance of that class that I am using for a store. And then all the normal rules of just utility functions and classes apply. When this component is unloaded, the class is destroyed, all the memory is freed up. It also saves a lot. It's just cleaner and more organized. So this is not the best example of some of the state management things, although I'll have to dig up some other ones because this is very simple. But there's a couple of interesting patterns going on here. So one, I'm using a reducer pattern in here, and I'll explain Ryan for just a second. But one of the advantages of rolling your own state management, I'll show you with a pattern that I like, is it gives you a lot more control and flexibility. So Akita has very specific use cases that it's designed for. And most of the time, it is actually really good at that. Like, we've been using Akita on a lot of projects. There are some times where it's not so great. And the thing that it's not great at, and I only discovered this on this project, is it's not good at managing side effects. And this is something NGRX is very good at. And for the most part, we're not doing a lot of side effects. Most of our CRUD apps, we get data, update data, send data back. Well, the map has an enormous amount of side effects. And so having a custom solution like this gives you a lot more flexibility on how you do it. So let's talk a little bit about like a custom state management implementation. So I want to stress this is not the best way or the only way. This is just another tool in the toolbox. And there are some pros and cons to using this sort of structure. And I'll talk through those as we go. So at any given time, we need to know the state object of the map. So we're following flux pattern, right? So we have a JavaScript object that is a central source of truth for state in our app. And let's go ahead and see what that looks like here. Okay, so if you look, here is all the things used to describe the app. Here is all the settings. Here is the map reference. This is in layerable, any layers that are attached, any data sources, any markers, any active markers, any actions that we need to perform, any status such as clustering or not. So these are everything. So if I take the state object and I throw it over the fence to another engineer, they can take this and looking exactly at how it's configured, regenerate perfectly the map that I am currently looking at. So for instance, let's say I needed to refresh the page. Well, if I stored this entire state, it's like it works almost exactly like a save game file in a video game. When I click save, I can restore this state and I get exactly to where I was in the app. Okay, here. Okay, so let me show you a really simple state management pattern. And this is actually how both Akita and NGRX work, kind of behind the scenes. You have a state object, which is just an object. And then you have an observable wrapper that is a behavior subject that wraps that object. That's it. And then when you are looking to make changes to this, I only have one function in right here called state change, which takes an action, and I'll get into that in a sec. So if you notice, it updates the state, and here's my reducer, and I'll show you that in a sec, and then it updates the behavior subject, and then that's it. And all the normal rules apply for state for any of your observable stuff. So this is always going to have the latest state object, and so you can subscribe to this pipe, map, distinct until change, all your normal stuff. Akita provides some of that stuff for free. The advantage is, look how lightweight this is. Just a few lines of code to kind of describe this. I don't have to instantiate the Akita store, the query. I don't have to do initial models. Like I don't have to do any of that. It's all set up. Okay, so let's talk about pros and cons of limit. So for those who aren't familiar with what a reducer is, it's a state management pattern that's currently used by NGRX poorly, I think. But what it does is, if you notice what is happening here, so a reducer is a pure function that takes state. So if you notice, here's the existing state of the app, and I am passing it the exact same thing, and then an action. So a reducer is a pure function that takes a piece of state and an action, and then applies that action to the state. Why is this great? Well, this is great because all state changes are flowing through this one reducer. This makes it really, really easy to see when you're dealing with side effects and race conditions. Let's say I have multiple API calls that are running concurrently, and A completes before B or B completes before A. Reducers don't care. They just respond to events. Where this is actually the biggest problem that I've had on my map here, where I'm using Akita, is I have a lot of side effects going on. So I click remove boundary, a couple API calls come, and and then depending on whether you have a term up here, it does 2 or 3 different things. If you're on certain zoom levels, so managing that entire flow of logic with asynchronous operations, kind of completing at different times in different orders. Some of my API actions are sequential, so A, B, C. Sometimes I have A and B firing in parallel, and one will complete before the other. Like, handling all that with Akita has been very, very challenging. Where if you run it all through a reducer, it doesn't matter because your entire state object is in here. So let's kind of take a look at, before I move on, any questions on reducers or actions, all that kind of fun stuff?
Yeah.
Go ahead. Hit me.
Go ahead, Brandon.
Okay. Thanks. I was just curious about kind of like, as you mentioned, like the sequencing and like the ordering.
Mm-hmm.
So if you have like, let's say 3 different asynchronous calls going on at the same time,
mm-hmm.
Does that mean, like, worst case scenario, you're going to have like 3 iterations of state change happen?
Yes.
Okay.
And the reason why that's okay is because you're not, like any observable, you're not watching the entire state change, right? Each person is only going to subscribe to 1 property or 2 properties, or you're going to combine properties with like a combined latest. So basically, the only time it updates is when something actually updates. And let me show you something that I don't super love. Let me show you why this matters, and it matters a big deal. So if you notice, all state changes are flowing through this function and this app. Let me show you an example where Akita is very problematic with so here is the Akita store that passes data to and from the map state service. Here's one of the problems with this. So if you notice, like, you guys don't have to dig in the logic. I have a function here called zoom change, and a bunch of stuff happens. And I have a function here called bounds change, and a bunch of stuff happens, right? And then I have a function called boundary lock change, and a bunch of stuff happens. Each one of these functions has its own business logic, passes its own API calls, and they can all be happening synchronously, asynchronously at different times. So it is actually very, like, I'll show you some good patterns for how to manage that, but it's actually really hard to keep track of what is happening when. So for instance, let's say I just a really simple race condition. I request an API call A and B, and B comes back first. So the boundary lock change function comes back before the bounds change. I have to add a lot more. It's actually really hard to handle with Akita because like, it's hard to know like what's changed or not. Where with the reducer, everything flows. Let me actually show you this in action here. So, okay. So because all your state changes are flowing through one function, you can actually see them happening very easily. So let me go ahead and uncomment this handy console statement. Let me show you why reducer is such a powerful tool for managing complex state. So I uncomment it. So let's go ahead and see what that looks like in my console over here. Provided it loads. Load faster. Come on. There we go. So we'll see what that looks like. It's going to be huge. So it gives you one source of truth for state changes. And this is extremely powerful. So let me show you. Let's just go ahead and let me make this a little bigger so you guys can see it. And it tells you exactly what's happening. So if you notice, a reducer, so let me go into, I'll talk about types or stuff. So it tells you exactly what's happening. So the first operation that happens is settings change. And now resize. And then we're adding some layers. And then data sources change. And then layers add. And you notice that the first data source, and it tells you what the payload is. So you notice there's nothing in this payload here. But if we get down further down here, you'll notice that I have a data source with a payload of clusters UI. And then down here, I have a data source change with 2 payloads in it, clusters UI and clusters server. So what it does is it is impossible to have sort of side effects and race conditions using a reducer, because all of your logic changes are flowing. So let's just say I had to add an out of order thing right here. So let's say data sources needed to be present before layers A. Guess what? I would see that in this flow of logic, where in my Akita store, I wouldn't see that. I mean, I can sort of see that, like if I put like a console statement in each function, but it's still really hard to determine what's firing. You'll notice that this is also synchronous. So this is the order in which the state changes are actually happening. So again, this happens first, then this happens, and then it also tells you what it did. So this makes it really, really easy to troubleshoot. So let's say I'm having a problem with settings, right? And I have lots of settings changes. I can look at here and I can find all the events that have settings, and then I can go into the payload and say exactly what was passed here. Oh, look, something is screwy going on with my zoom control. So it's basically like a snapshot in time. The other advantage is we're sort of seeing it here, is it lets you time travel a little bit. So we could actually keep track of these actions, and we could actually roll them back or roll them forward if we need to go back into like a certain level of state. Any other questions so far?
Yeah, I have one question.
Sorry, I'll ask after yours. I have another one. No.
Gerald, how do you handle, I know Akita had something, maybe that don't apply here, but I'm just trying to get food for thought for using with transactions. If you are using selectors over, when you put this in the class, are you still able to use that declarator that they have on Akita store, where if you're selecting multiple pieces and to keep it from emitting, if you're updating the store or not? Let's just say you had 3 selectors out there.
No, that's a great question. Yeah. Okay. So for those who haven't used Akita very much, Akita provides a function and a decorator called apply transaction. And what apply transaction does is it basically groups all of your state changes into a single transaction. So for instance, what you're seeing here is you have 3 or 4 operations that are all happening at one time. But let's say, like I actually use this a lot when making HTTP calls. So like a common example is I want to set the loading flag to true, and then I want to empty out the store. Well, if you don't use apply transactions, your observable is going to fire twice. Well, I don't want to fire twice. I could trigger a bunch of stuff. So apply transaction limits that, so only it updates one time. So this actually works very similar, because and the reason why Akita does that is a lot of the times Akita is only operating on one property at one time. So let me actually show you an example of that. So for you guys don't have Akita, let me show you a brief example of what an Akita update looks like. So here's an update statement for Akita. So you call the update flag, and then you pass it the delta of whatever you want to change. However, what I could do is use an apply transaction around this, but another alternative is to actually just apply everything that I need right here. So I could do something like 12. So here's another example of how to apply multiple transactions to an Akita store at one time. Now, the reason why a reducer works is, let's see, where's my store here? A reducer is only operating on one action at one time. So let's see, lost my train of thought there. Because a reducer is only operating on one thing at one time, any subscribers to state to one lower order state are only going to get the changes to the deltas. And to Reggie's point, if you have a subscriber to the core state object that's not looking at, you are going to see a lot of stuff. And so there isn't an equivalent to apply transaction. However, because all your state changes are flowing through one reducer, it's actually not as needed as much. So let me give you an example of that. So if we look at my reducer, I'm actually doing a bunch of stuff. So here's my map loaded action. I'll show you what actions and typeguards look like in a sec. So when an action comes in saying load the map, I actually need to transform state a lot. So you'll notice I create a new instance of the map using the payload. I set some camera options. Depending on X or Y, after business logic, I add some markers. I make some layers changes. I make some data source changes. Like I do a lot of stuff on load. And then what happens is after it's done all that, it sends me back only the completed state. So So basically, I pass it in action, it goes in there, and it does an enormous amount of business logic. Changes this, adds this, updates that. But when it comes back to the state object, it's all complete. It's like basically the final state. Does that make sense?
Make a lot of sense.
So there are some use cases where it might, like an applied transaction might be useful, like if you had to do multiple operations, but you probably wouldn't handle that here. You'd probably handle that in your downstream observers in like a combined lattice, just kind of watching this stuff. But yeah, good question. Brandon?
Yeah. One other thing about state change, particularly about errors. Like let's say state change was called like 5 times and some type of error occurs on the 3rd call. What happens to calls like 4 and 5? Does the error kind of stop the rest from happening? Do we just continue onward?
Okay. So this is actually a really tricky question because we have to determine who is handling the errors. So in the case of, let's say it's like an API error. Well, Azure Maps does not care about the component does not care about your API, like how you connect to the data and get, like it only cares about the completed result. So for an example, it's like an API error that needs to be handled external to this component. Now, for your specific question is how do we handle errors from within the component?
Yeah.
So I haven't actually had any errors with this component, but what you would do is you'd have something on your state object. So if we look at our state object, and so I would do if I need to do error handling, I'd have something on here called errors, right? So let's say, I don't know, something failure to instantiate, right? Maybe we wrap something in a try catch. What you would do is you would just call your store with an action that sets an error, and then all your downstream subscribers to that error object just handle it however they want.
Oh, okay.
Right? So again, that's the nice thing about this approach when you have a state object like this is like, that's a great example of a use case. So, when I initially started, I only had these. And then as my app grew, I added these and these. And so, my client Brandon comes back to me and says, hey, I just noticed that if I click on this button weird, I get an error. How do we want to handle that? Well, what I can do is I can just extend my state object, right? So I can add an error object, and then I can go into my template, right, HTML, right? And I can put an error object that says if error.state, output the text. And now I've added, and then I can create an observable that watches that state change, and it's all sort of follows kind of our standard patterns.
Oh, okay.
Make
Awesome.
sense?
Yeah.
That is actually a great question, is error handling. And it's one I don't have an answer to. Who handles the errors? So you've actually got 2 choices. So one is I handle the errors in my internal app, right? So I could do that. The other option is I emit the errors to the parent to handle. So, and we're actually doing this in Azure Maps because we don't want 2 different error types. We just, if there's an error, whether it's an API or something, we just want to pop one error message. So in this case, we're not handling any error messages in here, but like sometimes maybe you just want to emit the error, and that's a case-by-case basis. The other thing that's kind of smart to do is you can emit events whether people need them or not. So like let's say Brandon the client says, okay, hey, I want to handle error messages a little differently. Guess what? It's really easy to extend. I add another output here that says something like, on error, right? And then I would add an observable to my store that would say something. This is a little hacky, but you'll get the hang of it. This dot store dot state, dot pipe map x dot error dot sub this dot error dot emit, whatever. So now what I've done is, you notice how quick that was, right? So in just a few seconds, kids are being loud. So if you notice in just a few seconds, I added an error message. I subscribed to that error message, and I am now emitting that error message to the parent in order to operate whatever transaction. So when you have something organized like a state object, it is very simple to extend is kind of your use cases kind of matter.
Gotcha.
Any other questions? Okay, so let's go into a couple. So I got 15 minutes left, and I'm probably going to run out of time. And I want to show you a couple of cool patterns here. So, so if you notice, my reducer is pretty clean and lightweight. So I'm at 200 lines of code. And let me show you and this is kind of a functional programming paradigm that I want to show you guys that Russell and I have been using for quite a while and that I really like, is that's the use of utility functions. So I mentioned earlier, don't use services. And the reason for that is obviously, we went over that, but how do I break up my code into smaller units, and services are a good place is use the mighty utility function. So something that you'll see, I like this pattern a lot, is you have you notice my core class is also pretty small too. So I am at 300, sub 300 lines of code, not too bad. A lot of this is just the instantiate method. But now things get messy when I use my reducer. And let's use an example. Let me show you an example of what this looks like. So if you notice, I have a utility function in here. So I have my base class, or actually this is a function. And this is where functional programming is extremely powerful. So I have a utility function here called layer change. And if you notice, what this utility function does is let me fully encapsulate some business logic and let me reuse it somewhere else. So let's see what this looks like. Okay, so this is something we stress a lot, is use pure functions for everything. So if you notice, there's actually a lot of logic in this layers change. Call it 60, 70 lines of code. So a couple of things are happening. One, this lets me reuse this very easily. So if you notice, I actually have several instances of this on the map. So I'm using it here, here, and there's just my enclosed. I'm using it in 2 different locations. So one, this lets me reuse functions in a very simple manner. But 2, this forces you to use pure functions. So for those of you who aren't familiar with pure functions, a pure function is essentially a function that has no side effects, has no race conditions, and doesn't basically access any scope outside of what it was given. And what this means is that utility functions are almost perfect when it comes for modifying state, because you cannot get state that you're not allowed. You don't get side effects, you don't mutate state. So it makes it really, really simple for doing large scale state changes. Let's just see what this looks like. So layers change is the function, and you pass it whatever that function needs to modify. So in this case, when I'm changing the layers, I'm passing it the map, I'm passing it the layers file, and I'm passing it settings. And if we look at what this guy does, pure function. So you notice there's nothing in here that there's no state for it to access. So this sort of prevents you from making a lot of really bad design decisions. It's one of the problems, with object-oriented code, is it's really easy to start accessing stuff outside the lexical scope of which you've been provided. Where when you have utility files, it forces you to write pure functions. And it's a little bit, if you're not used to using these guys, it's a little bit to wrap your head around. The more you use them, the more you realize, holy crap, it is not possible for this function to throw an error. Given the same input, it will always produce consistently reproducible results every time. And there's no way for me to access scope. This is usually what I use as sort of my core unit of composition. So let's just see what it looks like. There's a lot of logic here. We don't have to pay attention to this. Do I have an existing layer? So remove it, yada, 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 yada. It's very, very simple, and boom, done. So couple of advantages. One, I love these from an organization standpoint. So if you notice, my main reducer here is really, its job is just a dispatcher. It's clean, it's lightweight, it just manages the events, but the actual heavy lifting is done by utility functions. So instead of having a 3,000 line reducer, I have a 300 line reducer, and all of the heavy lifting is done by utility functions that modify state. And it lets me organize it. So if you notice, I have all these utility functions here that work specifically on one piece of business logic. So I have a utility file that manages just callbacks. So here's all my callbacks. I have something that manages my data sources. Here's all the logic for managing data sources. I have layers. Here's all the layers. So a couple of things. So one, this lets me keep a ton of logic off sort of my core dispatcher. So it keeps it lean, lightweight, clean. 2, makes it really, really easy to reuse logic. So I'm only using it in 2 cases here. But back in my map store, there are some times where I'm using utility functions 4, 5, 6 times. 3, it makes it tree shakeable. So let's say I get rid of this utility function and I forget to delete it or whatever. Guess what? The TypeScript compiler is smart enough to see that I haven't oh, he's not actually using this function. He can strip it out. And the last big advantage is just organization. You'll notice that if I need to make changes to layers, guess what? I have a file here called layers, and all my business logic for layers is in here. It makes it nice and simple, reusable, all that kind of fun stuff. Any questions on pure functions, all that kind of fun stuff? Sweet. Okay, So let me go into, since I only got a few minutes left, let me go into like reducer pattern essentials. So we've looked at the reducer. So here's your reducer. It's really simple. It's just a big function that takes your initial state and then an action for how to modify that state, and then it returns it after you've modified it. That's it. Clean, simple, lightweight. But how do we know how to modify that state? And that's where actions come in. Let's go ahead and see what these look like. So let's see here. Okay, so inside my actions file, I have two things here. I have an action that corresponds to an action, and then I have a type guard, which I'm calling as action here, which lets me get proper TypeScript type. And let me just show you very simply what it looks like. So an action is just, let's see here, let's look at the model, where you basically tell it how to modify your app. So it's basically an object with a type. So in this case, I'm using enums just for good type safety, and the payload of how to modify it. And the advantage to using an action is it's type safe. So if you notice, the reducer, like how do we get type safety in the reducer? Everything is flowing. So if you look, I may have 5 different types of actions. How do I get type safety? Because everyone's flowing through one thing. So what your action is type safe. So if you use action.mapLoaded, this action is going to require you to pass it the correct data. Let's see what that looks like. Excuse me. So let's see what that looks like. Let's see here. Okay, so perfect. So if you notice, so let's say, so here's an example. If I want to change the camera on the map, so the user clicks zoom or they click the button, I want to change the camera. So you notice it's calling my state change function, right? And now I'm passing an action of camera options. And because camera options is a type safe factory, it is going to require the correct type. I can't pass it the wrong type. So in this case, it is requiring a type of NTS camera options, and that corresponds to the type from the input. So basically, it forces you to create, it only allows the correct type. And then when you're in the reducer, let's see, let's find that. Where's that corresponding type? Give me a sec here. Where's my actions? Now, this is called a type guard. And let me show you the secret sauce here. So if you notice that my response type, so this is just, if you notice, this is just a callback function, right? But the difference is I've said, I've specified what the return type is. And let's look at the camera example. So if you see here, if you call is_type camera actions, it's gonna, if you notice, I don't actually know what's being passed here. But I can tell TypeScript that, hey, this is always going to return a type of camera options if it meets certain condition. So in this case, if p.type is equal to this enum, we know exactly what the action type is. And TypeScript's TypeScript compiler is smart enough to know. So if we go ahead and look at our reducer, let's see, camera options. We'll do the standalone one. Okay, so now is we're using the type guard. So if you notice, I says if camera options actions, I have just now told TypeScript that if it passes this condition, it is an action and it knows what type it is. So if you notice, I have perfect type safety through this. So when I do a set camera action, even though I'm using action.payload, it is the correct type and I have perfect type safety. So if for some reason I tried to change this or I added a model, it works perfectly. Very, very handy. And the nice thing about type guards is they're useful not just in reducers. So a couple of examples, like I have is nil, right? So you can filter out null and undefined variables. Like I use a lot of union types. So let's say I have an array that has multiple object types in there. TypeScript doesn't know if it's type A or type B. When you have a type guard, you can basically say, hey, is this, and it will properly handle all the logic for that type. It's a pretty handy tool in the toolbox. Okay, check my agenda. We're doing okay on time. Okay, any questions on that so far? Cool. Okay, let me go into some advanced TypeScript usage, specifically union types. Let's see here. All right. Perfect. Okay, so let's go ahead and let me go just talk through an example. And I got 3 minutes left, so this is probably going to be pretty quick. How do union types work? So TypeScript is very smart when it comes to these sort of things. So in the map, we have something called a data source, and a data source can be one of many different types. So how do we get perfect type safety when we have multiple classes that have a lot of overlap, but there's some differences between the two. So let me kind of show you how I rolled this up. So inside I have a base interface called data source. And this has, here's all the things the data source needs. It needs an ID, it needs some options, and you notice that my type is perfectly typed. So here's all the types of data sources that you can supply, and then bounding box information. And you notice that I now start to roll up. So now here's an example of feature collection extends data source. And so now you notice that I have locked in type and the delta. So if you notice, even though both of these, so if we look at the difference between this, here's a multi-polygon type. You notice that it doesn't have features. It has something called coordinate. And so when you do something like this, TypeScript is smart enough to say that if you say if is type equals multi-polygon, it knows that you're supplying this interface for it and will give you perfect type safety for this. So let's see if I can do an example. I think I might have to punt that for another time just because we've got 2 minutes. And you'll notice I have another type here called polygon, and each one of these has different models. And then they all roll up into one type that I am exporting called data source. So here's your union type. And so the advantage of this is, you notice I'm not exporting my lower order models. The only thing I'm exporting is my parent model. So this means that when parent models are using this, it will force you to specify all the correct parameters for the correct data source. So let's say, you have a mix of polygons and multi-polygons. Well, if you put type polygon in here, TypeScript will require you to have the correct nested type. It's smart enough to know that. If you put multi-polygon, it will require the correct nested type. And I think I'm out of time. I want to save like a couple minutes for questions. All right. All right, sorry, that's kind of an abrupt end, but I also want to kind of respect people's time because I know it's getting lunch and it's getting later for kind of our East Coast things. Questions, comments, things you want to see? Because we can have multiple training sessions. Anyone?
Great job.
It was terrible. I didn't learn anything. What a complete waste of time. So I am.
Yeah, I had to turn off the brain siphon, like at certain times, so I could pay attention when things got applicable to my current project. But yeah, very useful.
I did record this. I will post it to YouTube. So if you want to review some of the more advanced stuff, I am also keeping a list of things that people have been asking me to teach. So I do know I've had some engineers asking me to teach about server-side rendering. I know something that is thrown a lot of our new guys is we have strict null checks enabled, and that's new if you're not used to that. So I am keeping track of stuff to teach, and I'd be more than happy. So if you guys have any stuff that you'd like me to cover, please let me know, and I can cover it in future sessions. I'm hoping that not all front-end Fridays will be me jawboning for an hour. So maybe I might be able to do more of them if we do shorter ones. But yeah, we'll see. Okay, any other questions, comments? Cool, it's quiet. So we ended at 12 sharp. Unlike all my client meetings, which go over for an hour. I'll post a link to the recording if you guys would like to review it at your leisure. And thanks everyone for attending. I really hope you guys learned some stuff.
Thank you.
Thank you.